Good day to you. This is David Pye of Pye Metallurgical International Consulting, located in the United Kingdom. And today we're bringing to you part 2 of vacuum furnace leak detection in conjunction with HT courses of Mumbai in India. This presentation will discuss leak detection using helium in conjunction with a residual gas analysis unit. We discussed the difference between what is a real leak as opposed to an apparent leak in the previous presentation. But we're still not sure if the leak is real or apparent at this point in the procedure of leak detection. Once again, we will start with the thermal procedure to prepare the furnace to be cold, clean and empty. We go through first of all conditioning of the vacuum furnace. Soaking at set temperature for approximately 2 to 3 hours. That's at the set point temperature, its normal operating temperature, or slightly above its normal operating temperature. Once we've accomplished 2 to 3 hours soak, turn off the heating cycle and allow the furnace to cool down under low pressure conditions. The cycle is run at the lowest obtainable vacuum within the capability of the vacuum pumping equipment. This will allow the vaporization of unwanted process byproducts by outgassing. Pump the furnace down to approximately, or as close as the pumping system will take it, to that of a value of approximately 1 micron. To vacuum furnace leak detection checking, to conduct the leak up rate, check the pump furnace, take the pump furnace down to its lowest pressure determined from the pumping system on the furnace, with the heat turned off and the furnace cold at approximately 20 degrees centigrade or below that temperature. Make a note of the vacuum level and the time. Then isolate the furnace from the pumping system by closing the vacuum valve or valves to the furnace process chamber. Allow the furnace to at least 1 hour to achieve the accurate leak up rate. Record the start time and finish time and subtract the start time from the finish time and the vacuum level. The furnace leak up rate is the difference in the vacuum levels divided by the elapsed time, and it's expressed in microns per hour. Should the final calculated leak up rate be faster or greater than 10 microns per hour in the process heating chamber, it is an unacceptable leak up rate. Please be aware that the furnace leak up rates between 50 and 100 microns per hour are not uncommon for integral quench vacuum oil quench tanks furnaces. Using the helium mass spectrometer test method. The helium mass spectrometer is a very accurate instrument for detecting extremely small leaks. This is where we're looking for the needle in that very big haystack. It will be necessary to isolate specific areas on the furnace, and in order to identify the specific areas as to where the leak might be, and allowing helium to sniff around that specific area. This non-destructive technique is often used to check all parts of the furnace apertures and parts that might be a leak source. The residual gas analyzer can detect extremely small amounts of helium or another tracer gas. The helium tracer gas is the gas of choice, and it's usually chosen because it is completely inert and it's non-toxic. Nor is it too expensive and not easily absorbed. Remember, it's the lightest gas that we have next to hydrogen. Helium also easily flows through small leaks and only a trace presence in the air of 5 parts per million. Remember that while you might have a tight furnace, there may be other areas of the furnace system that might be supporting that leak. When leak testing a vacuum furnace, do not forget to check the gas backfill lines. This includes all of the furnace fittings and piping from the gas supplies to the furnace. We're now ready to leak test the complete furnace module and its pipework. It is now good practice to use children's plasticine or Play-Doh to use as putty around all of the apertures of the furnace, such as main furnace door with the furnace door closed and under maximum vacuum operational conditions. All thermocouple feed-throughs into the furnace must be sealed with the plasticine. All power feed-throughs into the furnace must be sealed with the plasticine. All pipework feed-throughs holes for the gas delivery system to the furnace must be sealed with the plasticine. All joints that have valves, solenoids, etc. must be sealed with the children's plasticine. Fan drive system is also fitted to the furnace and it too must be sealed with the children's plasticine. The furnace is now under low pressure conditions and totally sealed. Now we must begin the sniffing with the helium gas. Remember, and this is a common problem, remember that helium is much lighter than air. If we, for example, start sniffing with helium on the underside of the vacuum process vessel, which causes an alarm to occur on the residual gas analyzer, and we look for that leak like crazy at the bottom of the furnace, but it could be a leak that's up on the top of the furnace. This is because helium is lighter than air, and because the size of the helium molecular structure, it may well be that the low pressure condition is pulling the helium from where we think the leak is positioned at the bottom of the furnace, when it could be that the leak is really at the top of the furnace. So now we have misinterpreted the audible signal from the residual gas analyzer, and we focus our attention at the base of the furnace, when in reality the leak is at the top of the furnace. So now we waste valuable time. For vacuum leak testing, using helium as the sniffer gas, we must start at the top of the furnace, checking one aperture at a time. We simply remove the children's plasticine from that one part of the furnace that we're testing, test it, and then replace it. Replace the plasticine. Once we've completed the check on that particular aperture, we must now reseal with the children's plasticine or Play-Doh and move to the next joint or aperture. This is quite time consuming, but it's absolutely necessary. It must be done one aperture at a time with the Play-Doh off on that aperture and replaced by the next one. Using the technique of helium leak detection, you can leak test to find smaller leaks than with other test process methods. The method makes use of a dry system, using a largely temperature independent but dry technique. This should result in a longer product life. And there are two basic techniques: high vacuum testing, which allows leak test thresholds to be set down as low as 1 × 10⁻12 millibar, or sniffing, which is generally used for helium leaks down to 1 × 10⁻6 millibar. For reference, 1 cubic millimeter per second is approximately 1 × 10⁻3 millibars, or 1 cc is approximately 1 millibar liter per second. This concludes this presentation of helium leak detection of vacuum furnaces. It is hoped that you've been able to gain some benefit from it, or perhaps a better understanding of this method of leak detection. Presentation has been brought to you by HT Courses of Mumbai in India and Pyrometallurgical International Consulting from the United Kingdom. We thank you most sincerely for your participation and your interest in what we are doing. We welcome your comments from you and your questions. Thank you sincerely, David.